Okay, hold on. Do something else as well. Okay. We would like to make a revision on the sedimentation topic. Okay, as you can remember, we have been producing bigger size of particles at the flocculation tank, whether we are using hydraulic or even mechanical. Okay, the purpose is just to form bigger size of flocks so that it can be removed in the sedimentation process. Okay, so what we have learned on the sedimentation a few weeks back, about a month, I mean perhaps nearly 2 months ago. Okay, so this is the assuming that this is a sedimentation tank. Okay, there are a few things that you have to remember. The flow rate symbol, which is Q. So I allow you to take pictures of this. If you want to do that, then you may. Okay. And then that is the flow rate. The water comes from the hydraulic tank. Okay. So this is the flow rate. And the surface area of the sedimentation tank is also important. And it is being symbolized as AS. And the height of the tank is symbolized as H. I also mentioned, I think, if I'm not mistaken, a few months ago, that in the sedimentation tank we have two kind of velocity. The first one is the velocity of the particles itself. We label it as Vs, or settling velocity. And also, not only the particles is traveling in the sedimentation tank, we also have water traveling in the sedimentation tank. So it is known as V naught, or overflow rate. Okay, so I mentioned to you that the Vs has got to be very, very, very big, okay, compared to the V naught, in order for us to have a successful sedimentation process. Okay, right? And what is V naught? V naught is actually H divided by T, or Q. This is Q divided by AS. This is the formula that you have to remember, and it will not be given in the exam. Okay? The only formula, perhaps, that has got to be remembered. So that is something that you need to remember, ataupun we refresh what we've learned um, in the last month, in February, if we like. And then there are two types of questions in sedimentation. I did mention that. The first one is V naught is given. So we would like to find the effectiveness, or we call it also as total removal. We symbolize it as RT. Okay, V naught is given, so find the effectiveness, or the RT. What are the RT? That's one question, and we have covered it in our first face-to-face lecture. But today we're going to continue on the another kind of question, whereby the effectiveness, or the RT, is given, and we have to find the V naught. Okay, it's the opposite direction. So let's do it. So how do we? Okay, now we look at that. Okay, look at our sedimentation slides. Okay, this is a picture of sedimentation. It's already. Okay, those are the equations. So I just want you to remind you on the equations. Okay, remember the scale up factor, whereby we used to have. I said that if you want to design the sedimentation tank, we need to do an experiment using settling column. So the results you obtain from the settling column has got to be times, we multiply with the scale up factor, which is 0.65 for overflow rate and 1.75 for detention time. Never mind, although it's very long time ago. Okay, so we have already covered the first example, I think late in the evening at that time. The data that is being given, and I believe that some of you have already done the assignment. Okay, so more or less like this. And then once you are presented with such data like this, the first step is to plot a graph. Okay, look at this kind of question. The overflow rate is 2 per meter square per hour. Then we were expected to find the effectiveness of the settling column. So this they are asking you for effectiveness of settling column. So you don't have to times with the scale up factor, because it simply says find the effectiveness of settling column, not the sedimentation tank. Right. So from that data, we plot graphs. So we already plot all these points and the y-axis and x-axis. And remember, we were given the V naught, which is 2.7 meter cube per meter square per hour. Okay. So our next step, after we have already drawn our graph, we need to obtain the value for t. Okay, so how do we get the value for t? Okay, so we know that V naught is equal to h divided by t. So our h was the column, the height of the column. If you remember, it was 1.8. Okay, from our table, we know it. Then the V naught is given 2.7 meter cube per meter square per hour. So we calculate this and we obtain the value to be 40 minutes. That's why we find 40 minutes and try to measure the RT at this point. So what is the formula of RT? RT is basically delta H. Okay? After you got your point and you start drawing your delta H, okay, this is the graphs. Okay, have been plotted. These are the ISO concentration lines, if you can still remember. Okay, have been drawn, and along this ISO concentration line, the removal are all the same. Like for this example, for this line, it's 70%. For the top line is 100%, and this one is 60%. The third line and the fourth line is 54% removal. Okay. The RT is actually H1 divided by the total height of the column times this percentage, which is 100 plus 70 divided by 2. Just like that, okay? 0.46 divided 1.8 plus 100 times 100 plus 70. Okay, this is 70% line divided by 2. And then we need to add up the second delta H. So we have to do that. Okay, 0.5 divided 1.8 is the total height of the column. Time, this is line of 70, and this one is line of 60. Then you have to add both numbers and divide it by 2. And then the last part is to obtain the delta H, which has been measured by by me. Okay, so that value is 0.79 divided by 1.8, and this line is 60%, and this line is 54, and then you plus them together, divided by 2, and you calculate these values, and you will obtain the value to be 66.6%, which have already been done, which have been already been calculated by you guys during our first lecture. Isn't that right?
Yeah.
Yeah, that's great. Okay.
Sir,
Yes.
can you explain to me again how to get R1, R2, R3, and R4?
R1, R2, R3, and R4. Delta H, you mean?
No. For formula RT,
Okay.
can we have R1 plus R2 over 2, right?
For this one, you mean the value?
Yes, the value.
70.
R1 is 100%, right?
Oh, I see. All right. Okay, I know what you mean.
How you get R2 is 70, R3 is 60,
Okay, right.
R4 is 54. Can you explain to me?
Okay, it does not really matter actually. It's not necessarily 70. This is the line that you draw. you yourself draw, or we feel that we would like to draw 70% line, then we draw 70% line. How do we draw that? Perhaps that was the questions. Okay, so the first line is 100%. Okay, it's basically a straight line parallel to the x-axis. That's the first line. The second line, okay, just in case you do not like 70%, which is fine to me, okay, you probably like 72%. So this is, you know that this is 72% line. So this is 62. I hope that everyone can see. And this is 74. You have to measure where 72 can be. Perhaps 72 is there. Okay. That means you can draw 72 lines, point from this is 72 point. This is another 72 point. So you draw one line linking this point and that point and just extrapolate it to 0. So we will be having 72% line. And if you like to draw another line, let's say we are interested with 60% line. So this is definitely 60. So from this data, you can see that 58 is here, 62 is there. You have to measure. It's not just guess, okay? You have to measure to be sure that this probably has got to be 60% point. So just link those points and extrapolate. Okay, this one is 59, this is 62. So we assume that we don't assume, we measure it to be this one is 60, for instance. So you have to basically connect this 60 to this 60 to that 60, forming a line, an iso concentration line of 60. Okay, so you can always draw as many lines as you like. But okay, if you have drawn too many lines, so your calculation will be very long. Okay, I wouldn't deny the fact that the more lines you draw, okay, the better, the more precise the answer. But it will take time in the exam. Okay, perhaps drawing 1, 2, 3 lines will be better for examinations. That would be enough, I think. Okay, do not be too lazy. Just draw one line. At least 1 to 3 lines will be better. We'll be okay. We'll be fine. I really hope that it answers your question.
Sir, I have another question. If we look at example 1 table,
Number 1, okay.
minute for time 40, depth 1.8. The percent removal is 54.
Right, that's right.
If I want to make 50%, can or not?
I mean the line.
The removal.
You want to make 50% line.
Yes.
Yes, but it's no use. Okay, because 50% line, you see this one is 54. 50%.
54. Yes.
50 must be around here. Okay? So if you draw that line, it does not hit your T. Your T is at 50, at 40. Your T, okay? The time you obtain from the
Oh, yes.
So there's
Now I understand.
all right, okay? So
To intercept the T, right?
yes, it must intercept the last point. I think that's a good question.
Oh.
Last point or whatever. Whenever you find your T, let's say for this case is 40. Let's say you do another calculation. Perhaps they change the V naught. So let's say your T is 50. So you must know what is the value for that T. If you don't know that, so that will be a disaster. Okay. So you really need to know. Let's say if the T is 50, yeah, in different examples. Okay. Let's say the T is 50. That means since we have this 54 and that's 59, that you have to measure. You've got to measure. Perhaps this is one is 57%. So that means your dust point is 57, and the height now, the delta H3 now has changed. You know, from this is 57, this is line 60. So the height now is definitely going to be smaller than 0.79 because that is the only height. And then the delta H becoming different delta H from there to there. And then delta H1 will be different delta H1 from there to there.
Oh, okay, sir. Thank you.
All right. Okay. Never mind, this topic is being recorded. So after we finish this lecture, inshallah, I will put it in my web page so you can always try to come back and understand it again. Now we go to the second part, the second kind of questions. First part, if you remember, the V naught is given. So we like to find out the percentage of removal. Okay, let's say as a civil engineer, you were asked by your boss, okay, design a tank that have V naught of 27 meter per hour, for instance. Okay, so what would be the removal? So this is what you're doing. Okay, the previous example is actually to find out the effectiveness of that tank. Now it's a different situation. Your superior asks you to design a tank whereby it can remove 65% of the suspended solid. So what would be the V naught? Okay, so this is the question now. So they are asking you to design a tank that removes 65%. So what would be the V naught? That means what would be the T, the detention time? How long the water stay in the sedimentation tank so that it can perfectly remove 65%. Okay. Right. We have already been given by the data. We have given the data, which is so easy. So the data are given. So as usual, we need to plot a graph. So you have already got your graph there. Okay. It is in your notes. Okay, I'm not sure which page is that. What page is that?
57.
Yeah, that's right. Okay. So 57. So how do we go about this? So you see this person is very hardworking person, have drawn so many lines. Okay. He loves drawing lines. By all means, they may do it. Okay. So the first thing that we need to do is to choose any time that you like. Let's say for this case is time 35. 35 minutes, 0.58. So I choose this time. So I also want to say something, okay? Sorry. Okay, you make a table. Okay, if anyone would like to snap these pictures, you may do that and then can put it in the WhatsApp groups, okay? So I choose the first time was 35 minutes. So they have already changed it to hour, okay? And then we can find out the overflow rate. Okay, remember? Oh, sorry, I forgot to show the height of the column just now. If you look at this table, okay, the height of the column is 2 meters. That means given H is 2 meters, then the overflow rate is V naught. So H is 2 divided by T. Our T was 35 minutes, so that would be 0.06. So I change the unit to meter per day. This one is meter per minute. So meter per day to 82.3 meters. Okay. So with that, we have already obtained those values. And then the next step is to find out the RT. Okay, the overall removal at T is equal to 35 minutes. Okay, at that RT, and then you have to have your first delta H1, which is 0.1 meter. So you can see 0.1 meter, the total height is 2 meter column. And then this is line 100, and this one is line 75%. So our RT could be like that. Come on. Okay. So our RT at 35 minutes, RT is 0.1 divided by 2. 2 is the total height of column. And then we have iso concentration line of 100 plus 75 divided by 2. That is the first delta H1. And then we go for the delta H2, which is 0.2 meters. Remember, this line is 75% line, and this one is 70% line. Okay, so the height is this delta is 0.2. That means 0.2 divided by 2 times 75 plus 70 divided by 2. Yes, that's right. Okay, so like that. Okay, do again the same thing. Find out our delta H3, which have already been measured by me with enthusiasm. Okay, so the distance is 0.15 divided by the total height, which is 2, and then this line now correspond to 70, and this one is 65. So 70 plus 65 divided by 2, 0.15 divided by 2, the height. So we look at our next part. Divided by 2, that's correct. Okay. So again, we do it till the end. Okay. Delta H4 now, and that distance or that height, okay, is actually 0.25. 1, 2, 3, 4, 0.25. And we look at it. That means 0.25 divided by 2, 65 plus 60. And then delta H, 1, 2, 3, 4, 5. Delta H5, the height is actually 0.3 meters divided by 2. And this line is 60 and this line is 55. 0.3 divided by 2, 60 plus 55. Okay. Alhamdulillah, it's going to be our last delta H. And that height is 1 meters divided by 2. And this line corresponds to 55% line. And this one is 50% line. And we eventually will obtain the results or the RT removal to be 59.4 or 60. Okay, so it is on your page 58 on your book. 58. It could be for the time being, the book being that we use is on page 58. Right, so you've already got your RT for time 35. Then the next step is I want to put it in the table here. So that's one is, which I have forgotten. I think 60% was it, wasn't it? 60%, right?
Yep.
Yeah, thank you so much. Now, okay, we haven't finished yet. Okay, we have already got one time, so we choose another time, whichever time that you like. As for my case, I prefer to choose this time at 45 minutes. Okay, at 45 minutes, that means I 45 minutes here. Automatically, my Excel will calculate the time in hour and also the V naught in meter per day and also meter per minute. So my task now is to find out the RT. Okay, so we have to do the same thing again. Find out that delta H and another delta H and another delta H and another delta H and another delta H. Okay, so we have to measure all of that and do the same thing. Okay, find out the value of all that. So I'm sure that you do not like to do that. Usually each and every single delta H there and then keep adding 100 plus 75 divided by 2, 75 plus 70 divided by 2 as a long tedious job. So I have simplified to you guys. So I've done it myself. So it's actually 63%. 63%. Okay. So now our task is to find out another time. Okay, our second time is 45 minutes, which is equal to 0.75 meter per hour, 0.75 hours. And then my third time is 76 minutes, which is equivalent to 1.27 hour. We have to find out our delta H and another delta H and another delta H. And I've already do the calculation for the RT, and the value for the RT is 68%. Okay, 68%. So our time was 76 minutes that I chose. Okay. Then I got the RT to be. So what is the next step? We've already got all this data. Anyone would like to take photograph of this?
Yeah.
Okay, take the photograph first.
Please send in the group, yeah. Thank you.
Right.
Right. So once you have already obtained this data, okay, we must be focused on what actually we need to find out. Okay. They like to design a settling tank to remove 65%. So we like to see the removal of 65%. Removal of 60%. Once you've already got this data, you've got to plot the time and RT. RT against time. I've already done that. Which is that? It looks like this. Okay. So you have got a nice curve. So you've got to see the RT, the percentage removal of 65% from there. And we are hoping that the time would be 0.8. This is 1. So it's about 0.9 something, perhaps 94 or 95. Okay. So that's how you know the time. Okay. So why do we need to know the time? Once you know the time, that means if you have a sedimentation tank, okay, the water coming from the flocculation tank has got to stay in that sedimentation tank for 0.9 hour, 0.95 hours. Then only it will be able to remove 65% of the particles. That's what it means. Okay, right. Not only that, that is the time. Now, okay, we also have to plot another lines. Okay, RT against the V naught. So I've already got the this is the RT, this is the V naught. So they said that they want to see the 65% removal. So look at your 65% there, bring it here. So the V naught is actually a little bit more than 50. So something like perhaps 52 or something. Okay, 52%. That means you remember the second type of question, they give you the efficiency, which is 65%. You have to find out the V naught. So this is the V naught that you want to find. This is 52. Okay, so that is the process. It's a bit tedious. You've got to plot at least 2 graphs. Okay, why I say 2 graphs? The first graph is graph. Okay, and then it has to proceed with at least one of these, either this or that. Actually, you don't have to plot 2, but I'm showing that you can plot 2 if you are so hardworking. Okay, so you just plot 1, you get the 65%, and then you've got 1 time. And then from that time, you can also find out your V naught. Yeah, you see, because the height is always 2, so the column is 2 meters, then divided by whatever time that you have from here. Okay, don't worry so much. Okay, if you don't understand, you can always refer to the
Doctor, can I take picture the graph slide?
this one.
Yeah.
No. Okay, I'll make a bigger. Hold on.
Okay, then.
So that you want to see all this color thing.
Yeah.
Yeah. All right. That's it. Is that okay?
Done.
Done. Okay, good. Okay. Right. So we continue with our slides. Right. So they actually have already drawn the diagram for you. If you refer to the figure B, so this is a plot for the RT against H, the one that I've also drawn it in the Excel. So if you're not mistaken, if you want to see, this is actually 0.58 hour, which is equivalent to 35 minutes. Our first data, you see the removal is 60%. And that point is the 0.75 hour, and that is correspond to 63% removal. And this point is actually 1.27 hour, which is equivalent to 76 minutes, and that corresponds to 68%. Then you have your 65% there. This is 60, there's 70, so 60% is in the middle. You draw one line there, and we have to go down to find out our H, which is 0.9 hour or equivalent to 54 minutes. I'm sure that you want to take the graph of this. You may do that. Okay.
Okay.
Right. Can I change to another slide?
Yes.
Okay. You have taken photographs, of that, right? I assume you have. Okay.
Yes.
Right. Okay. We look at figure 6 also. This is the plot of RT against the overflow rate. The same thing. Okay. That is 82.3, which is the V naught that you produce when you have times is equal to 35 minutes. And it gives you 59.4. And then we have another point, 64 V naught. This is when you have the 45 minutes time. And that will give you the RT to be 63. And then the last point is one, okay, 37.9, and that will give you 68% of the RT. And then we are interested with 65, so 65 is there. Go down the line, we'll obtain our V naught to be 50 meter per day. Okay. Okay, can I move to the next slide? If you look, read really careful on the questions. Okay, so shall I go back to which slide is that? I think it's probably 21. No. Okay, design a settling tank. Remove 65%. So they want a data for settling tank, but these are using the column. Okay? They want to design a tank, but this data is from the column. So do we need to do anything with the result that we have obtained? Okay. You see, you have already obtained your not 50. Okay, so this is from the experiment using settling column, but we would like to design a tank. Do we need to do anything with these results? Do we have to times anything, perhaps?
No.
No. Okay. No or yes? We have to manipulate.
No.
That's a good attempt, but in reality is we have to times with a scale up factor. Because we are doing the experiment using settling column, that's not real. That's in the lab. Okay, that's a settling column of 2 meters. Now, if you want to design a tank, a real tank, okay, the height of the tank is 2 meters. So you need to times or to multiply with the scale up factor. So your V naught is 50 and our scale up factor is 0.65. So for the real design of the tank in the real world, okay, would be the V naught is 32.5 meter per day. So is the case as the time. The time from our graph, we obtain it to be 54 minutes. You need to times with the scale up factor because this one is from experiment. We are designing the real tank. So you need to times with the scale up factor. That means the time in the tank, the real tank that you would like to design has got to be 95 minutes. Or in other words, the tank that you design, make sure that the detention time in the tank is 95 minutes in order for you to remove 65% of the suspended solid. Okay?
Okay.
Right. Yeah, I really hope that you guys understand. Otherwise,
Doctor, the scalar factors is fixed or we can get in the question.
it is a fixed value.
It's a
Exactly. It is being informed in the exam. Not in the exam, in the notes. Okay.
Oh, yeah.
Whether it will be given in exam or not, it really depends on the lecturer who set up the questions. Some lecturer they are kind. They tell you the scale factor. Some lecturer may not be that kind. They assume student memorize it. So it's probably worthwhile for you to memorize the scale out factor for T and also the scale out factor for the V naught. Okay. I am not going to set the question on sedimentation, so do not ask me. Okay. So I was assigned to make questions for some other topics. Right. Everyone okay? You want to take break? We take break after we finish sedimentation topic. Is that okay?
All right.
Okay.
Okay.
So finish sedimentation topic, then we take break. I also want to drink. You also want to drink, or perhaps look after your family or something like that. Okay, we go to the example 3. Okay, example 3 is this. Notice that the numbers are different from your in the book. Okay, you follow my number, not the book's number. Okay, change it now. You have your book with you, perhaps in the office, and you cannot get it. So just take pictures of this. Sentence are, I think, the same. It's just that the number are different. Okay, follow my number. One is 20. Your book is 43.2, if I'm not mistaken. Then you have this one, the different ratio, and also different V naught. Okay.
All right.
So look at the questions. A rectangular sedimentation tank. Okay, it's not a round type. It's a rectangular type. It's to be designed with a flow of 20 million liter per day. Flow means this is the Q. Okay, Q is equal to 20 million liter per day using 2:1 length width ratio and overflow rate of 20 meter cube per meter squared per day. This one, if you can cancel each other, so this one cancel and it becomes 24 meter per day. It's the same. Okay. The tank has to be 2 meters deep. Determine the dimension of the tank and the detention time. I think I would like to extract this question into diagram. So we have a rectangular sedimentation tank, and it says that the Q is 20 mld. Okay. And also they say the ratio of length to width is actually 2:1. So you can do the, I do not know what we call it in English. I call it darab silang. Okay. The cross multiplication, I think. So that is L is equal to 2W. And we also were informed of the depth. Okay, that's the ratio of length and also the width. And then they mentioned on the height of the tank, which is 2 meters. Okay, 2 meters. And the overflow rate was also given, 24 meter per day. So they want you to find out the T, the L, and also the W. And you remember V naught is what? Can someone tell me the equation for V naught? Something that you have to memorize?
V naught.
Equal to the formula for V naught.
Oh, for me.
Height over time.
Thank you so much. At least someone knows. Thank you very much. I assume that everyone knows actually. H divided by time. So V naught is already there. We have already got our H. So it's very easy to find our T then. Okay. Yes. Remember V naught is equal to H divided by T and Q divided by AS. Right. So with that, so T is equal to H divided by V naught. Our H was 2 meter divided by this value, 24 meter per day. And you have to turn upside down, by times. So it turns upside down. If you times, so that means you have to turn upside down this number. So meter and meter will cancel. So you got 2 divided by 24 is actually 1 divided by 12. whatever the value is. So I like to change it into minutes, into hours, sorry. So this is multiplication here is for the conversion units. So meter cancel with this meter, day cancel with this day. So you end up in hour. So 24 divided by 24 is 1. 2 hour. So the result will be, so you may write it down. Perhaps, I believe you would like to take photograph of the previous slide, won't you? You want to take photograph of this? Not important.
I want to take photograph.
Okay. Do it. Okay. Then change to the next slide, right? Okay. We have already found out the tension time. Want me to proceed?
Yes.
Okay, so are you guys writing down or taking pictures?
Writing.
Oh,
Writing.
Both.
Wait.
very impressive. Thank you, thank you.
And taking picture.
Oh, that's great. Finish, just give me a shout, right? I don't know. Okay,
All right.
next slide.
Okay.
Okay, right. Okay, the question asking you on the detention time, which we already got, have already obtained. That's not a problem. So they also ask you to find out the L, the length of the sedimentation tank, and also the width of the sedimentation tank. Okay, so we know that the volume, the V naught is equal to Q divided by AS. So the Q was given. I think the Q was 20 mld. If I'm not mistaken, was it? I can't remember. Yes, 20 mld. Okay. The Q was 20 mld and AS is given now. AS is equal to Q. Okay, we bring it V naught underneath. So Q divided by V naught, 24 meter per day. So you have to change this. Basically, if you divide this number, that means when you times, you have to turn it upside down. And then another factor is just to change liter here to meter cube. We times with the conversion factor. Day we cancel with this. So eventually we get your area in meter squared. So perhaps you would like to solve that first. So tell me your AS value. You got the answer?
It's 11 o'clock.
This is not supposed to be. This is not 106. Okay, that's supposed to be the power of 6. The answer is given already. So very clever move. So the answer for AS is 833.33 meters squared. Okay, so we have not finished because we need to find out the length and the width. So you know that AS is actually length times weight. Okay, can I continue? Can I proceed?
Yes.
So AS is 833.33 meters squared. We know that L is equal to 2W. That means the AS is equal to L times W. And that is 2W times W. And that is 2W squared is equal to 883.33. And then rearrange your W and do that. Okay, 833.33 divided by 2 and square root the answer. And you will eventually get your W to be whatever things that you would like to find out. Okay, do your maths first. And then find out your L as well. Anyone? W and L.
Um, one.
Sorry, the value of L, W.
W 20.4.
12.4.
20.4.
Yes. W 20.4 and L.
40.8.
0.8.
Okay, yeah. W is 20.41 if I'm not mistaken. L is 40.8.
Yeah.
Right. So we have already finished the sedimentation. Okay. Just a diagram of the real sedimentation tank. Then they have scraper. You see, this is sedimentation tank, so the suspended solid goes down here. So this is the scraper. You scrap all the suspended solid, and eventually all the suspended solid sludge will be and outside here through this valve of the thing, if you like. Okay. So okay. So do we have questions on sedimentation before we take break? Doesn't anyone share their pictures, their own video at home? At least I can see. No questions. Take break now. Okay, we have almost full house participation. The participants, 29 participants. Again, I said that the video is recorded, so inshallah I will put it in the in my web page, and always refer for topic for sedimentation. So can we discuss on the past year question later? Can we do that later? Let's just focus on finishing off our lecture first. Okay, I think I want to teach sedimentation, and then we go for hydraulic flow later. Then only the balance of the time would be discussing on your exercises if you want. There is no questions. We take break for 10 minutes. So my phone that is 5 minutes. So we start at 11:15. Is that okay? Yeah.
Okay, okay.
Okay. Thank you, everyone.
Thank you.